Good day, dear students. Today, we're going to have an in-depth discussion about SQL table join operations, which are crucial skills in big data processing. 1. Why table joins are necessary. In real-world big data scenarios, data is often stored in different tables. For example, one table stores users' basic information, while another stores their purchase records. When we want to obtain both users' information and their purchase details simultaneously, we need to use table join operations to integrate these scattered data for analysis. 2. Several common types of table joins. Inner join. Principle. An inner join is like finding the common ground between two tables. It returns the rows where the join keys of key equals BKEY matched in both tables. As you can see from the diagram, only the parts with the same key values in Table A and Table B are selected. For instance, if Table A has user IDs and usernames, and Table B has user IDs and the products they purchased, an inner join can get the complete information, username, and purchase products of users who have purchase records. SQL syntax. Select list from Table A inner join Table B beyond a .t equals b.t. Here, select list represents the columns you want to query, and the on keyword is followed by the join condition. Application scenarios. Use it when you only care about the data with matching records in both tables, such as counting customer information for those who have placed orders. Left join. Principle. A left join gives priority to the left table, table_A. It returns all rows from the left table and the matching rows from the right table based on the join key. If there is no match in the right table, the corresponding columns will be filled with null. Just like shown in the diagram, all rows from Table A are selected, and where there is no match in Table B, null is displayed. SQL syntax. Select list from Table A left, join Table B, B on A.key equals B.key. Application scenarios. Use it when you want to get all the information from the left table along with the associated information from the right table. For example, when you want to view all users, regardless of whether they have purchase records or not, right join. Principle. Opposite to the left join. A right join gives priority to the right table, table_B. It returns all rows from the right table and the matching rows from the left table based on the join key. If there is no match in the left table, the corresponding columns will be filled with the NUL. SQL syntax. Select list from Table A right, join Table B on A.key equals B.key. Application scenarios. Use it when you care more about all the data in the right table and the associated data from the left table. For example, when you want to count the sales situation of all products, even if some products haven't been sold corresponding to no matching records in the left table. Full outer join. Principle. A full outer join returns all rows from both tables. If a row in one table has no matching join key in the other table, the corresponding columns will be filled with null. As you can see from the diagram, it combines the results of the left join and the right join, including all rows from both tables. SQL syntax. Select list from Table A. Full outer join Table B, B on A.key equals B.key. Application scenarios. Use it when you need the complete set of data from both tables, regardless of whether there is a match. For example, when integrating two data sets from different sources and you want to keep all possible records. 3. Points to note. Selection of join keys. Make sure that the selected join keys are logically related in both tables. Otherwise, you'll get incorrect results. For example, you can't use a user ID and a product ID as join keys. Performance issues. In larger scale data scenarios, table join operations can be time-consuming. Use indexes reasonably to optimize join performance, such as creating indexes on columns where the join keys are located. In conclusion, mastering these table join operations proficiently is of great importance for you as big data majors in data processing and analysis. You should apply them flexibly according to specific requirements in actual projects.